Another one. Okay, so COCl2, this is phosgene, a very deadly and dangerous chemical. Was used a lot in the world wars in chemical warfare. And the only reason I'm using that is because it's a good example of the next shape that we want to do. Okay, and you can sort of see that on the webcam, but let's draw the structure. Remember that we always, if we have carbon, we always start with that. Okay, carbon's got 4. I'm going to put the oxygen over here. Oxygen's got 6. Then I've got 2 chlorines. Hold on, let me go back and fix that. I know my drawing leaves a lot to be desired. You'd think after a month or so I'd be used to the pen, but apparently not. Okay, so 7 electrons around that chlorine. Bond them up, nothing terribly tricky about this one. I'm going to double bond the oxygen. The reason I do that is because I pretty much have to. That's the only way that carbon and oxygen are both going to have their filled octet. Okay, so that means that when I clean this molecule up, that it's going to look kind of like this. So oxygen and chlorine and another chlorine. Okay, and you can see that down here if you look in the webcam. Okay, if you look down here in the webcam, we've got 2 chlorines. Okay, and an oxygen. You see the double bond there. And this one has a pretty unique shape. If you look at it, you're like, okay, sort of triangular. But if you turn it like sideways, it's all together in one plane. Okay, it is actually sort of flat. So this one actually does kind of look like the 2-dimensional model that we had. But let's jump back to our chart. Okay, probably would have been good if we'd erased last time's stuff. Let's jump back to our chart and talk about what this particular molecule has. Okay, so real quick, jump back to the molecule in case we forgot. I've got 1, 2, 3 total pairs. Remember that this, the double bond, that it counts as 1. Okay, so let's just write that down real quick just so we don't forget. So I've got 3 total, and those are all 3 bonding, and I've got 0 non-bond. Okay, so jump back here to the chart. So it's got to be one of these two. I've got 3 total pairs, and I've got 3 bonding pairs. So that means that it is trigonal planar. Okay, so let's jump back and write that name down for that one. Okay, so trigonal planar. Okay, and what does that look like? Well, if you look in the webcam here, it's a triangle shape, okay, so like 3-sided almost, but it's all in one single plane. We can lay it so that it's completely flat, so everything's all together in one plane. So that's trigonal planar. Okay, let's try a couple more. The ever classic water. So we've done the shape for water before, but we'll write it out real quick just to make sure that you see how all the steps work out. Oxygen's got 6, each hydrogen has 1. Bond those suckers together. And so this is what we've got in the case of my oxygen. Whoops. One of these days. One of these days. Okay, so got that. And so how many total pairs do I have here? Well, I've got 1, 2, 3, 4. I've got 4 areas, 4 clouds, so 4 total pairs. I've got 2 bonding. Okay, and I've got 2 non-bonding, or as we would normally call them, lone pairs. Okay, these are called lone pairs or non-bonding. Okay, so again, hop back to our chart. Okay, and you guys, again, you've got the chart in front of you, so make sure that you're using it. So in this case, we've got 4, so we're down here kind of where we were before when we did methane and ammonia. I've got 4, but in this case, I've got 2 bonding, 2 non-bonding, and that means that my shape is bent. And again, that makes pretty good sense. If we looked at the actual shape of a water molecule, okay, that's exactly what it looks like. It is bent. It looks like it's bent. Okay, now again, what's the reason for that bent? Well, these 2 lone pairs are going to push the hydrogens away. I mean, you might be thinking to yourself, wouldn't it be easier if I just drew water like this, you know, where it was in a straight line? It would be great if that's actually how water was, but it's not. Those 2 lone pairs are pushing on it. They repel them and push them away, the bonding pairs away from each other and away from themselves. So that's what's going to give water its bent shape. Okay, Another thing that makes water really unique and gives it some of those unique properties. Okay, let's try one more before we finish up here, and that's going to be carbon dioxide. So carbon, oxygen, something about drawing these electrons. Pick the pen up, Glenn. Okay, so bond, bond, bond. Kind of drew that kind of sloppy, but there's my other bond. Okay, and this, of course, is why you have to clean things up. So now you'll notice I didn't draw the extra electrons. The only thing I'm really worried about the extra electrons is the central atom, because the shape is all determined by that central atom. So what do we have here? I've got, it looks like I have 4 pairs, right? But remember, double counts as 1. Okay? Okay, double counts as 1. So I've got 1, 2 areas then. So I've got 2 total. And they're 2 bonding and 0 non. Okay? So hop back to ye old chart. One of these times I'll remember to erase before I leave the page. Okay? So what do we got here? We've got 2 total, 2 bonding, 0 non-bonding. And that gives me a shape of linear. And again, that makes pretty good sense too. I mean, if you looked at that molecule, it looks like it's going to be linear because it's all in one line. Now you're thinking, well, yeah, but I thought the water was going to be linear too, but it didn't turn out to be linear. Well, here's the deal. What makes carbon dioxide a little bit different is that it has double bonds in it, okay? And those double bonds lock everything into place where they can't twist around or bend. And I've only got 2 regions. If I've only got 2 things, how far apart can they get from each other? Well, 180 degrees. They want to be as far away from each other as possible. Okay, guys, I know that's difficult. Go back and watch this again if need be. Just make sure that you follow the steps, okay, rule by rule when you're working on these today. And I may try to post even up a couple of videos that are examples on the homework stuff that you're working on, okay, or the classwork that you're working on for this Vesper stuff, all right? Thanks, guys.